Greetings! Quick question to everyone out there. Ever tried counting sugar grains one by one? Now imagine counting atoms. They're so tiny, it's impossible. Atoms are so small. Counting them one by one? Not happening. So how do chemists keep track of atoms? That's where the mole concept comes to the rescue. A mole is like a dozen, but for atoms. In chemistry, particles are super tiny and super numerous, so we use a much bigger number. Scientists pick carbon-12 as the reference. 12 grams of carbon-12 has exactly 6.022 times 10 to the power of 23 atoms. That's Avogadro's number. This number is named after Amedeo Avogadro, an Italian scientist. Now let's move on.
As we know, 1 mole is equal to 6.022 times 10 to the power of 23. Sir! Yes? Sir, but how do we use actually this in our calculation? That's a great question. Let's work through a real example, shall we? For the example, we'll use oxygen atom. The molar mass for oxygen 16 is 16 grams per mole. Now what does this actually mean? It means that let's imagine this ping pong ball as 1 mole of oxygen atom, meaning that this single ball weighs about 16 grams in mass. So to solve our problem, there's a few steps that we need to do first. First, we need to identify our values, which is mass and molar mass. So let's look through our question. It is given that oxygen is 24 grams. That is our mass. Now what about our molar mass? Now let's look through our periodic table and find for oxygen. Now oxygen here stated is 16 grams per mole. And after identifying our value, let's just substitute it into our formula. That's for the step 2. So 24 grams over 16 grams per mole. I don't have a calculator with me, so sir, can you help me with this?
The answer is 1.5.
Absolutely, thank you sir. So it is 1.5 mole.
Good job, Rizwan.
But sir, how do we actually relate mole and Avogadro constant?
Good. Now here's the cool part. Since we know that 1 mole atom is equal to 6.022 times 10 to the power of 23, we can multiply that with the number of mole that we already got.
Ooh, I got it now. Now I know that the number of moles is connecting mass to the numbers of particles. So basically, once you know the molar mass and the Avogadro constant, you can basically convert between them all three. Alright, chemistry detectives, let's bring the mole concept into something that you can see and touch.
Now, imagine this marble is not just a marble. It's a single carbon-12 atoms. So, if we were a tiny chemist, this is what we will be working with. However, that's not the case. Atoms are way too small to be counted individually.
Just like how a dozen egg mean 12 eggs, 1 mole of particles means 6.022 times to the 10 of power 23. And let me show you how this works with our marbles.
So first, we need to find the atomic mass of this one single marble. This one marble weighs about 5 grams.
If 1 marble is exactly 5 grams, and we know that 12 grams of 12 carbon-12 atoms is exactly 1 mole, then 12 of our marble should be exactly 60 grams. And that 60 grams should be exactly to our 1 mole of marble atoms. Now let's look at this together. So in this jar already have 11 of it. So if we put our 12 marbles inside of it, and look, it's exactly 60 grams. And this jar full of marbles is exactly our 1 mole of marble atoms in our analogy. Now, why do this actually matters? Now, instead of counting millions and trillions of invisible atoms, chemists can now simply measure mass on a scale and know exactly how many particles they have. The mole itself gives us a bridge between the microscopic world of atoms and the measurable world of grams. And that, my friend, is how we count the uncountable.